Hello everyone, welcome to the Arch Linux installation guide. The installation process of Arch Linux can be a little bit intimidating for new users, especially when they first launch the live USB and all they get is the black TTY session. One thing about Arch Linux is when you log into the live USB, all you get is the command line to install your system. In comparison, Ubuntu uses the Ubiquity graphical installer, so all you have to do to install Ubuntu is just click next, next, and next. It's so easy that even a dummy could do it. This is okay if you just want to get a system up and running as soon as possible without any headaches, you're on a stable system that you can rely on, and you're okay with using what the system has to offer right out of the box. However, you won't be able to learn anything new by just hitting the next button a few times. On the other hand, installing Arch will require to do everything manually, and that includes installing and activating your network manager service, or you won't even have something as basic as an internet connection. Now this has made Arch Linux into a meme distribution where a lot of people start to use Arch Linux just so that they can get a special kind of ranking and go to forums, IRC chats and comments and post a screenshot of their desktop and say, "By the way, I use Arch." However, if you're new to Linux and you just want to start learning about Linux and you don't know where to start, you're lost, congrats, you've just found your answer. Start by installing Arch from scratch. With that said, I absolutely don't encourage new users to run Arch Linux and use it as the main daily driver unless you're ready to pull every single strand of your hair off. By just installing Arch in a virtual machine, you will have gained a lot of Linux experience and you don't even have to run it on your main machine. Okay, before we start the actual installation, I just want to emphasize that in this video, we will be installing Arch Linux in UEFI boot mode. So if you're planning to install Arch Linux in BIOS mode, there will be a link to another video in the show's description. Okay, before you install Arch, you have to get the Arch ISO and flash it to a USB drive. This step is pretty universal, so I'm not gonna show you how to do that in this video. This is the boot menu of Arch Linux. One little quirk that I encounter all too often is this boot menu not showing up and it kicking you directly into the UEFI shell. It doesn't happen all that much, but I still thought that it was a good idea to mention it just in case. It really just depends on your firmware. If this happens, simply type exit. Yeah, it's really that simple. Let's boot into Arch Linux. First thing that we are going to do here is verify that we are indeed booting with the UEFI boot mode. Run als/sys/firmware/EFI/EFI vars. If you get a list of EFI variables, then you're good. However, if you get some errors, chances are you are booting with the legacy boot mode, so stop this video and check out the legacy BIOS counterpart video in the show's description. The next thing that we're gonna check right now is our internet connection status. So I'm gonna run ping space google.com space -c space 3. And I see that my internet connection is up and running. If you can't connect and you are using a Wi-Fi connection, you might want to consider making a wired Ethernet connection instead. Alright, let's set up the time now. So, type timedatectl space set-ntp space true. It's that simple. With that done, it's time to partition our drives. Before proceeding, I want to say that it's probably for the best if you do this in a virtual machine if this is your first time doing it, because chances are you might make an accident and send your other partitions on your hard drive to a bottomless hole. Let's start our disk partitioner tool with cfdisk. Now on a typical UEFI installation, we use the GPT partitioning scheme, so that's what I'm gonna select. In here, we are gonna create three main partitions: the EFI system partition, which I'm just gonna call ESP to save time, the swap partition, and the root partition. Selecting all the free space here, I'm going to create a new partition with the size of 512 megs. The 512 megs is a standard size of an ESP, that is the EFI system partition. Next, I'm going to set the type to EFI partition. Okay, I'm gonna create a swap partition next by selecting the remaining free space and hitting new. I'm gonna set a swap space of 2 gigs. If you don't know what size to set for a swap space, you can always just set it to be the same size of the amount of RAM you have. That's typically what Ubuntu's automatic partitioning option does during an Ubuntu installation. And I'm gonna select the type to be Linux swap. Alright, now let's select all of the remaining free space and create a new partition. And change the type to be linux-root. The x86_64 part here basically stands for the 64-bit architecture. Now before we proceed, I just want to explain a little bit about the usage of these partitions. The ESP, which stands for the UEFI system partition, is used to store the UEFI boot entries from your various bootloaders. And your system's firmware is going to search this partition for bootloaders. Now the thing about UEFI boot mode is that even if you have multiple bootable operating systems or multiple bootable partitions in one drive, all you need is just one UEFI system partition and all of your OS will store their boot entries in this one global partition. Usually it's necessary to format the ESP with the type vfat or FAT32, they are both the same thing. Alright, the next partition that we're going to talk about is the swap partition. Your system will use the swap partition whenever you are running low on random access memory. If you choose not to create a swap partition, there is still an option to create a swap file for Linux post-installation, no problemo. And the last partition, the root partition, stores all of our system files and directories. There are some Linux users out there who prefer to have their home partitions on a separate partition so that their user data and configurations can remain separated from the actual system itself. Of course, you can always separate your home partition after the installation. Okay, to make these changes, select right and type in yes to confirm. Select quit or hit Q on your keyboard to quit. Once the partitions have been created, we have to format them with appropriate file systems. Before I start though, make sure you know what your partition identifiers are from the cfdisk partitioner previously. The following steps are really dynamic in particular, and by that, I mean you can't just copy and paste my code or any code you find in other wikis and articles online. You have to be able to tweak the commands to suit your own system. For instance, my ESP is identified as /dev/vda1 and my swap partition as /dev/vda2 and my root partition as /dev/vda3. Your root partition's name could be something like /dev/sda3 instead. If you happen to forget your partition names anytime, you can run the cfdisk partitioner to check. I'm going to start by formatting our first partition, /dev/vda1, which is our UEFI system partition with the FAT32 file system. To do that, simply run mkfs.vfat /dev/vda1. mkfs means make file system and vfat is the same as FAT32. The next partition is our swap partition, so I'm going to run mkswap /dev/vda2, mkswap being make swap and /dev/vda2 being our swap partition's name. That's still not enough though, because we still need to tell the system to activate the swap with the command swapon /dev/vda2. With that done, let's format the last partition, our root partition, at /dev/vda3. So, run mkfs.ext4 /dev/vda3. A standard Linux installation always uses the extended for ext4 file system, but there are some people out there who would prefer to use other file systems like BetterFS or ZFS for additional functionality, but we are not going to worry about that in this video. Okay, we are done with all of those formattings. Now it is time for us to mount the partitions because we can't make changes to partitions that are not mounted. The first partition we should mount is the root partition. We will mount our root partition to the mount point /mnt and the ESP to /mnt/EFI, which is, by the way, the newest standard for an ESP mount point. The older standard being /mnt/boot/EFI. So you might still see tutorials out there telling you to mount your ESP to /boot/EFI. We don't have to mount the swap partition because we have already run the swapon command. Do take note that /mnt is just a mount point and the root directory will later be just a slash after we have finished our installation and loaded into the root partition. But for now, we will just refer to the root directory by its mount point, /mnt. So let's mount the root partition with mount /dev/vda3 /mnt. With that done, we have to mount our EFI system partition too, or it will be excluded from our file system tables file that we are going to generate later on. If we don't mount our ESP now, we will be faced with a lot of trouble down the road, especially when installing the system's bootloader. So let's mount the ESP with mount /dev/vda1 /mnt/EFI, and we get an error. That comes as no surprise because the mount point haven't been created yet. Luckily for us, it's actually pretty simple to fix. I'm going to run mkdir space /mnt/EFI. This command pretty much means make directory at /mnt/EFI. With that done, let's try to mount the ESP again by hitting the arrow up key a few times. There we go, no errors. And it's time to give ourselves a high five because we are all done with the whole disks and partitioning business. It is now time to select some local mirror servers. This is a very important step because if we don't select local mirror servers to download our packages from, the whole installation process can take like 3 times longer than it's supposed to be because we are downloading our packages from a server that very well might be on the other side of the globe. It is like a seriously huge waste of time and resource. Let's select the local mirrors with the command nano space /etc/pacman.d /mirrorlist. You can always hit the tab key for auto completion. In here, we will have a super long list of countries, and to search through it manually will take forever and it is a pain in the bum. So here's a neat little trick dedicated just for you. You can use the hotkey Ctrl+W to search for a string pattern in the nano text editor, and in this case our string pattern will be our country. Repeat the key binding to search the next string matching the search pattern, and use Ctrl+K to delete other irrelevant lines. It is also worth noting that there is a worldwide server that you can select just in case your country isn't listed in the list. All you have to do is search for it. You can have multiple servers selected here, and it's probably a good idea to have like say 3 servers remaining in this list. Just in case one of them fails, we still have another fallback one. This file will be copied over to our installed system, so it's worth getting right. Once you're done, hit Ctrl+O and enter to save and Ctrl+X to exit. Now that we are done with setting up our mirror servers, we can finally install the actual system itself. We will use the pacstrap command to install a few packages. So do pacstrap space /mnt space base space linux-lts space linux-firmware space nano space vim space sudo space man space dhcpcd. You can replace linux-lts with any version of the Linux kernel that you want, like linux-zen, linux-hardened, or just plain old Linux. But if you're not sure on which one of those you should choose, I strongly suggest you to just go for linux-lts because the LTS stands for long-term support and it is generally the most stable release that we can get. We can even upgrade the kernel to a newer version if we want to after the installation, but having the LTS kernel as a base can never go wrong. With that done, hit enter. So let's look at the packages that we're about to install here. Nano and Vim are both command line interface text editors. The sudo package is a package that provides the sudo binary that allows normal users to run commands as root, and the man program allows us to view manual entries, kind of like a help command to display documentations. And finally, dhcpcd is our network service daemon. Without dhcpcd, we won't get an internet connection, which is very bad because just imagine not having a network manager after we have finished with the installation. You won't even be able to download packages, and not even the network manager package itself. So to get out of that mess, you would have to boot into an external live USB like we are doing right now and arch-chroot into your system to rescue it. Oh geez, let's not do that right now. With that done, hit enter. Okay, this installation will take a while depending on your internet connection, so I'll cut back to the video once the installation has completed. It looks like our installation has completed successfully, but before we remove the live USB and boot into the actual system, we still have to settle a few things first. So the first thing that I'm gonna do is generate an fstab file. This file system tables file will give the system information about your mounted partitions and their respective file systems. So run genfstab space -U space /mnt space and 2 greater than signs space space/mnt/etc/fstab. You can check the resulting file and edit it in case of errors with cat space/mnt/etc/fstab. It doesn't look like there are any errors, so I'm just gonna move on with the next step. We can now artificially load into our installed system to make changes before booting into it directly by running the command arch-chroot space/mnt. Great! Now that we have loaded into our system, we can drop all of the /mnt's because there's no longer a need to make changes to our file system by referring to a mount point. Now let's set a time zone with the command ln space-sf space/user, actually it's usr/share/zoneinfo/region/city space/etc/localtime. Now before you hit enter, this command will create a symlink to tell the system how to adjust the time from the UTC time provided by your hardware clock to your local time. If you don't know what your region or city is, cancel the command with Ctrl+C and simply run ls space/usr/share/zoneinfo. Hit enter, remember your region and hit the arrow up key. This time though, fill in your region and hit enter again. Let's just say US for now, and you'll get a list of cities available. So once you have identified your region and city, we run the command ln space-sf space/usr/share/zoneinfo/ and enter your info accordingly. For me, it's gonna be pretty simple because I don't have to specify a city in my region. Now with that done, let's set up the system clock with hwclock space-systohc. This command assumes that your hardware clock is set to UTC, and it usually is. Next, run nano space/etc/locale.gen. In here, use Ctrl+W to find en_us.utf-8 and uncomment that entry by deleting the hash symbol preceding it. Next, uncomment any other needed locales, hit Ctrl+O and enter to save, and Ctrl+X to exit. With our selected locales uncommented, generate the locales by running locale-gen. Now run nano space/etc/locale.conf and type lang = en_us.utf-8 to set US English as the system language. Alright, now we are officially done with all of the localization, I promise. This next step is to configure our network. Run nano space/etc/hostname. Then in here, type in your hostname. Take note that your hostname is not the same as your username, but it is instead the name that your computer will appear as to other computers that are in your network. And then with that done, hit Ctrl+O and enter to save, and Ctrl+X to exit. The next command we should run is nano space/etc/hosts, and in here we're going to start a new line. Type in 127.0.0.1, tab across, type localhost. Start another line, type ::1, and then tab across, and then type in localhost again. Now enter a new line again, type 127.0.1.1, tab across, and then type in your hostname .local domain. And I'm going to type LG because that's the hostname that I specified from the previous commands. Then tab across, type in your hostname again. Okay, it's starting to get ridiculous if I have to say this even just once more. At this point, anyone will think that you should already know how to save and exit from this editor, right? No? Fine. Hit Ctrl+O and enter to save, and then hit Ctrl+X to exit. Now we still have to enable the network manager service with systemctl enable dhcpcd. This will only work if you have installed the dhcpcd package with the pacstrap command previously. The init system that Arch uses is systemd, and this line will tell it to start our networking services the next time we boot up. Time to set the password for a root user with the command passwd and type in your password twice. Don't worry if no characters show up when you do so because it's an intentional security feature. And yes, we have reached our last step before we can remove our live USB and boot directly into the actual system legitimately. But our last step is, of course, to install a bootloader, but more specifically the Grand Unified Bootloader, grub. To install grub, you have to first install two packages from the official repositories with our package manager first. The package manager that Arch uses is called Pacman, like the video game Pac-Man, but this Pacman is way cooler. It actually stands for the term package manager. So pacman space -S grub and EFI boot mgr. If you're dual booting, you might need additional packages like os-prober, but I'm not gonna do that because I just have one OS that I'm installing right now, and hit yes. And just a quick tip right here, if I rerun this command, you'll see that there's a prompt called proceed with installation, and there's a set of square brackets, and inside that brackets you can see that there is a capitalized Y / normal N. Now if I were to hit enter, Y will be selected as a default, so I don't have to manually type in Y like this and hit enter, it's just gonna be yes. But if N is the capitalized letter instead of Y, and it's like something like Y / N, and if you just hit enter, it's gonna select N, which is no as the default, and you don't have to type in N manually. And I don't want to reinstall because I've already ran this command before, so I'm just gonna manually type in N. Just a quick small tip there. Now before we carry on, we have to make sure that our ESP is mounted, and we have to be able to determine the mount point of said partition. So do ls-vlk, which stands for list block, and you can clearly see that our EFI system partition is mounted at /EFI. And yeah, for those of you who are wondering, it's just /EFI now and not /mnt/EFI, because we are already ch-rooted into our actual system and we no longer need to refer to the mount points. Okay, if you have installed the two prerequisite packages and your ESP is mounted, we can now install grub by running grub-install --target equals to x86_64-EFI for a 64-bit system, space --EFI-directory equals to /EFI or whatever your ESP mount point is. Then space --boot loader-id equals to arch. You can replace the bootloader ID with any ID you want, but make sure that there are no special characters like spaces in there. Now if you get any weird error messages here, the first thing that you are gonna want to do is check the syntax for typos, especially the x86_64-EFI part. A lot of people will leave out this -EFI part and just hit enter like that because they get confused with the following -EFI directory option. Grub is now installed, but we still need to generate a configuration file for it. So I'm gonna type grub-mkconfig space -o, which stands for output, space /boot/grub/grub.cfg, and then hit enter. Now if you make any changes to your grub configurations at /etc/default/grub, that's the typical place where we make configurations to grub, you will have to rerun this command again to refresh the settings, or you can optionally install the update-grub script from the AUR and the Arch user repositories for a shorter command. Debian and Ubuntu already has this command built in by default. With that done, let's exit from the ch-rooted session by typing exit, and let's shut down with shutdown space now. Now remove your live USB and power up your computer again. So let's boot into Arch. We are nearly there everyone, I promise. Now all that's left for us to do is create a new sudo user, install additional packages, and finally install a graphical environment to work in. I will walk you through all of those steps except for the last one, because from that point onwards, there are so many paths to choose from, so many separate ways that you can do things. And I'm not going to show you that because this video is just about a standard installation of Arch Linux, and no matter what desktop environment or window manager you choose to run, these are the essential steps that you have to go through anyhow. You can check out my video, The Map of Linux, to get a better understanding of the Linux system as a whole. Okay, with that out of the way, let's log into our newly installed system as the root user. So type root and type in the password that you have set previously. Now we're going to create a new user because it's just plain dangerous to be rocking the root user as your day-to-day user. So type user add space -m space -g users space -G real and then your username. Next, set up the password for the new user with passwd and the username for your new user. Type in your password twice again. And now we have a new user, but we still have to give this new user permissions to run commands as root. And to do that, we need to edit the sudo configuration file with editor equals nano space vi sudo. Once again, we can use the Ctrl+W hotkey to find real all. And if you see this line real space all equals all, just go in front here and delete that hash symbol right there. And then you can also use Ctrl+X and Y and enter to save and exit from the nano editor. Now that we have created our new user, we can type exit to exit of the root user session, and then we can log in as our new user. We have reached the last step of this installation guide. We will install some useful additional packages with pacman space -S space base -devil And base-devel isn't actually a package but a package group, so it contains a lot of necessary packages if you want to install the yay AUR helper. Next we have git, which allows us to clone config files from remote repositories like GitHub and GitLab. The following packages that I'm going to install are file system utilities like DOSFS tools, which allows us to mount DOS formatted partitions, and we have xfat-utils for xfat support, which is another Microsoft introduced file system, and then we also want e2fs progs for e2fs support, and then we also want ntfs-3g for ntfs support. Now ntfs is the file system that Windows uses, so this package is essential if you want to mount Windows drives, like if you're dual booting with Windows. If you want to mount macOS drives, you will need hfs progs, but this package is only available in the Arch user repository, so you'll need to install an AUR helper like yay. So if you want to install yay, there is a graphical way to do it, and I have another video tutorial for that, and link in the description as always. The last two packages that we're going to install are xorg and xorg-xinit, which are the graphical server backends. Xorg is a meta package, kind of like a group, so it contains a lot of useful utilities for managing the graphical server like xkill, xprop, and xrender. If you want a minimalist installation, you can always go for xorg-server. So instead of installing the whole meta package, you are just installing xorg-server, which is part of the xorg meta package. You only need these two packages if you're planning on installing a graphical interface later on. So hit enter, type in your password, and then you'll be able to see this is the base-devel group, and then I'm just going to install all of those things in that group, and then these are the packages that are included in the xorg group. So I'm just going to select all. Xorg is a graphical server backend, so on its own it's pretty huge in size, so it might take a while to install. With that, I am happy to conclude this installation guide. We now have a proper Arch system up and running, though we still don't have a graphical environment to work with. With that said, it's pretty simple to get one installed with a one-liner command, and there are so many choices, like a desktop environments such as GNOME, KD Plasma, Cinnamon, XFCE, so on and so forth. We could even just run a minimalist floating or tiling window manager like OpenBox, DWM, BSPWM, i3, or Awesome. Or none of those and just run Linux with just a command line interface like a server. I'm working on follow-up videos to this one, and we'll be installing graphical environments for a more usable workspace. So stay tuned everyone, goodbye.